Lighting in a Class 10,000 cleanroom must adhere to California's Title 24 requirements for energy efficiency. The entire electrical installation needs to comply with applicable codes and standards, including the National Electrical Code, or NEC. For the walls and ceiling, typically, gypsum drywall with a smooth, non-porous surface is used. Flooring should consist of epoxy-coated concrete or vinyl flooring with welded seams to prevent dust accumulation. The HVAC system requires high-efficiency particulate air, or HEPA, filters and positive pressure to maintain a clean environment. For conduit and cabling, electrical metallic tubing, or EMT, is commonly used, but it is crucial to seal it to prevent air leakage. Consider the HVAC design carefully. Ensure the HVAC system provides sufficient airflow and filtration to maintain the required cleanliness level. All equipment and furniture within the cleanroom should be made of materials that do not generate particles. Implement access control protocols to manage entry into the cleanroom and minimize contamination. Develop and implement training programs for personnel who will be working in the cleanroom, emphasizing proper techniques and procedures. Establish a regular schedule for cleaning and maintenance to keep the room clean. Here are some additional tips to consider. Firstly, consult with an experienced cleanroom design engineer or architect for expert guidance. Secondly, review industry standards and guidelines for Class 10,000 cleanrooms such as ISO 14644.1. Thirdly, visit existing Class 10,000 cleanrooms to observe the best practices firsthand. Fourthly, seek input from the cleanroom user to understand their specific requirements. Fifthly, consider utilizing advanced technologies like airflow simulation and particle counting to optimize the design. When considering materials, remember that low-shedding materials are crucial to prevent contamination within the cleanroom environment. Surfaces should be smooth, non-porous, and easy to clean and sanitize. Epoxy-coated or stainless steel components are commonly used due to their durability and resistance to particle generation. Proper sealing and gasketing are essential to prevent air leakage and maintain the integrity of the cleanroom. The design of the HVAC system is paramount for maintaining air quality and controlling particle levels. High-efficiency particulate air, or HEPA, filters should be used to remove airborne particles effectively. The system should provide adequate air changes per hour or H to dilute and remove contaminants. Positive pressure should be maintained within the cleanroom to prevent infiltration of particles from surrounding areas. Airflow patterns should be carefully designed to minimize turbulence in stagnant areas where particles can accumulate. Regular testing and certification of the HVAC system are necessary to ensure it meets the required performance standards. Personnel training is crucial for minimizing contamination and maintaining cleanroom integrity. Training programs should cover topics such as gowning procedures, proper cleaning and disinfection techniques, and cleanroom etiquette. Employees should understand the importance of following protocols and adhering to strict hygiene practices. Regular monitoring of particle levels and microbial contamination should be conducted to assess the effectiveness of cleaning and control measures. Access control measures, such as airlocks and pass-through chambers, can help to minimize the introduction of contaminants into the cleanroom. Routine cleaning and disinfection procedures should be implemented to maintain a clean and sanitary environment. The selection of appropriate cleaning agents and disinfectants is essential to prevent damage to sensitive equipment and materials. Cleaning schedules should be established based on the level of activity and the sensitivity of the products being manufactured or processed. Regular audits and inspections should be conducted to identify potential sources of contamination and ensure compliance with established protocols. When dealing with electrical systems in a cleanroom, several key aspects should be considered to maintain cleanliness and prevent contamination. Firstly, the selection of electrical components is crucial. Choose components that are designed for cleanroom use and certified to minimize particle generation. These components often have smooth surfaces, sealed designs, and are made from materials that do not easily shed particles. Secondly, conduit and wiring methods play a vital role. Electrical metallic tubing, or EMT, is commonly used for conduit, but it must be properly sealed to prevent air leakage. All connections and fittings should be airtight to prevent the escape of particles. Wiring should be neatly organized and secured to prevent dust accumulation. Thirdly, electrical panels and enclosures should be designed and installed to minimize particle generation. Enclosures should be sealed to prevent dust and contaminants from entering. Regular cleaning of panels and enclosures is essential to remove any accumulated particles. Fourthly, lighting fixtures should be chosen carefully to provide adequate illumination without contributing to contamination. Recessed LED fixtures with sealed lenses are a good option, as they are energy efficient and produce minimal heat. Fifthly, grounding and bonding are essential for safety and to prevent electrostatic discharge, or ESD, which can attract particles. Ensure that all electrical equipment is properly grounded and bonded according to the National Electrical Code, or NEC. Sixthly, regular inspections and maintenance of the electrical system are crucial to identify and address any potential issues before they lead to contamination. Check for loose connections, damaged wiring, and any signs of particle generation. Seventhly, compliance with relevant standards and regulations is essential. Past 10,000 cleanrooms must meet specific requirements for air quality, particle counts, and cleanliness. Ensure that the electrical installation complies with all applicable codes and standards, including the National Electrical Code, or NEC, and any local regulations. Eighthly, consider the use of low-voltage systems for certain applications to reduce the risk of electrical hazards and minimize heat generation. Low-voltage lighting and control systems can be a good option for cleanroom environments. Ninthly, proper labeling and identification of electrical components are essential for maintenance and troubleshooting. Clearly label all panels, circuits, and equipment to facilitate easy identification and prevent errors. Lastly, documentation and record keeping are crucial for maintaining a cleanroom environment. Keep accurate records of all electrical installations, inspections, and maintenance activities. This documentation will be valuable for troubleshooting and demonstrating compliance with regulations. By following these guidelines, you can ensure that the electrical system in a Class 10,000 cleanroom meets the required standards for cleanliness and safety. Consider the implications of California's Title 24 on the cleanroom's lighting design. Title 24 is California's energy efficiency standards for buildings, and it includes requirements for lighting power density, or LPD, and lighting controls. Firstly, lighting power density, or LPD, refers to the maximum amount of power that can be used for lighting in a given area. Title 24 sets specific LPD limits for different types of spaces, including cleanrooms. To comply with Title 24, the cleanroom's lighting design must meet these LPD requirements. This may involve using energy-efficient lighting fixtures such as light-emitting diodes, or LEDs, and optimizing the layout to minimize the number of fixtures needed. Secondly, lighting controls are another important aspect of Title 24 compliance. The standards require the use of lighting controls that automatically reduce lighting levels when spaces are unoccupied or when sufficient daylight is available. This can include occupancy sensors, daylight sensors, and dimming controls. These controls help to reduce energy consumption and ensure that lighting is only used when and where it is needed. Thirdly, Title 24 also includes requirements for lighting quality such as color rendering index, or CRI, and correlated color temperature, or CCT. These requirements are designed to ensure that the lighting provides good visibility and visual comfort for occupants. To comply with Title 24, the lighting design must meet the specified CRI and CCT requirements. Fourthly, compliance with Title 24 is typically demonstrated through a combination of design calculations and field verification. The design team must perform calculations to show that the lighting design meets the LPD limits and other requirements. After the installation is complete, the building inspector will verify that the lighting controls are functioning properly and that the lighting system meets the specified performance criteria. Fifthly, it's important to note that Title 24 requirements can vary depending on the specific occupancy type and the scope of the project. It's essential to consult the latest version of Title 24 and any applicable local amendments to ensure compliance. Additionally, working with a qualified lighting designer or energy consultant can help to navigate the complexities of Title 24 and develop a lighting design that meets both the energy efficiency and functional requirements of a cleanroom. Sixthly, consider the impact of Title 24 on the cost of the lighting system. Energy-efficient lighting fixtures and controls may have a higher initial cost than traditional options. However, the long-term energy savings can offset the higher upfront cost and result in a lower total cost of ownership. Seventhly, when selecting lighting fixtures for a cleanroom, it's important to consider not only energy efficiency but also cleanliness and durability. Fixtures should be designed to minimize particle generation and be easy to clean and maintain. Recessed fixtures with sealed lenses are a good option, as they prevent dust and contaminants from accumulating on the surface of the fixture. Eighthly, consider the use of daylighting to supplement artificial lighting in the cleanroom. Daylighting can reduce the need for artificial lighting and save energy. However, it's important to control daylight to prevent glare and overheating. Ninthly, when designing the lighting control system, consider the specific needs of the cleanroom occupants. Some areas may require higher lighting levels for certain tasks, while others may benefit from lower lighting levels. The control system should be flexible enough to accommodate these varying needs. Lastly, it's important to document all aspects of the lighting design, including the lighting layout, fixture specifications, control system configuration, and energy calculations. This documentation will be valuable for maintenance and troubleshooting and for demonstrating compliance with Title 24. By following these guidelines, you can ensure that the lighting system in a Class 10,000 cleanroom complies with California's Title 24 requirements for energy efficiency and provides a safe and comfortable environment for occupants. Electrical metallic tubing, or INT, is a common choice for conduit in many electrical installations. However, in a cleanroom environment, there are some additional considerations to keep in mind. Firstly, sealing ENT is crucial to prevent air leakage. Cleanrooms are designed to maintain a specific level of air cleanliness, and any air leakage can compromise this cleanliness. EMT connections are typically made with compression or set screw fittings, which may not provide a completely airtight seal. To prevent air leakage, it's important to seal all EMT connections with a suitable sealant or tape. Secondly, consider the material of the EMT in fittings. Standard EMT is typically made of galvanized steel, which can corrode over time, especially in humid or corrosive environments. In a cleanroom, it's important to choose materials that are resistant to corrosion and will not generate particles. Stainless steel EMT and fittings are a good option for cleanroom environments. Thirdly, support EMT properly to prevent sagging and vibration. EMT should be supported at regular intervals to prevent it from sagging or vibrating, which can create dust and particles. Use appropriate hangers and supports that are designed for cleanroom use. Fourthly, avoid sharp bends and edges in the EMT installation. Sharp bends and edges can create turbulence and increase the risk of particle generation. Use smooth, gradual bends and deburr any sharp edges to minimize these risks. Fifthly, clean EMT thoroughly before installation. Before installing EMT in a cleanroom, it's important to clean it thoroughly to remove any dust, dirt, or debris. Use a cleanroom-approved cleaning solution and wipe down the EMT with a lint-free cloth. Sixthly, consider the use of flexible conduit for connections to equipment. Flexible conduit can be used to connect EMT to equipment that may vibrate or move. This can help to prevent stress on the EMT and reduce the risk of air leakage. Seventhly, avoid running EMT through areas where it could be damaged or contaminated. EMT should be routed away from areas where it could be damaged by equipment or personnel. It should also be protected from exposure to chemicals or other contaminants. Eighthly, inspect EMT regularly for signs of damage or corrosion. Regular inspections can help to identify and address any potential issues before they lead to contamination. Check for loose connections, corrosion, and any signs of damage. Ninthly, consider the use of cable trays or ladder racks to support EMT runs. Cable trays and ladder racks can provide a neat and organized way to support EMT runs, especially in large cleanrooms. They also make it easier to access and maintain the EMT. Lastly, document all EMT installations and inspections. Keeping accurate records of all ENT installations and inspections can help to ensure that the system is properly maintained and that any issues are addressed promptly. By following these guidelines, you can ensure that ENT is installed and maintained properly in a Class 10,000 cleanroom, helping to maintain air quality and prevent contamination. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including those in cleanrooms. Firstly, Article 500 addresses hazardous locations. While a Class 10,000 cleanroom is not typically considered a hazardous location, it's important to be aware of the requirements in Article 500 if there is a potential for flammable gases, vapors, or dust to be present. Secondly, Article 300 covers wiring methods and materials. This article provides general requirements for wiring methods and materials, including conduit, conductors, and boxes. It's important to choose wiring methods and materials that are suitable for the cleanroom environment and that comply with the NEC requirements. Thirdly, Article 314 addresses boxes, conduit bodies, and fittings. This article provides requirements for the installation and support of boxes, conduit bodies, and fittings. It's important to ensure that these components are properly installed and supported to prevent damage and maintain the integrity of the electrical system. Fourthly, Article 250 covers grounding and bonding. Grounding and bonding are essential for safety and to prevent electrical shock hazards. Article 250 provides detailed requirements for grounding and bonding electrical systems and equipment. Fifthly, Article 400 addresses flexible cords and cables. Flexible cords and cables may be used in cleanrooms for connecting equipment to power sources. Article 400 provides requirements for the use of flexible cords and cables, including limitations on their length and use. Sixthly, Article 410 covers lighting fixtures, lamp holders, and lamps. This article provides requirements for the installation and support of lighting fixtures, lamp holders, and lamps. It's important to choose lighting fixtures that are suitable for the cleanroom environment and that comply with the NEC requirements. Seventhly, Article 600 addresses electric signs and outline lighting. If electric signs or outline lighting are used in the cleanroom, Article 600 provides requirements for their installation and wiring. Eighthly, Article 700 covers emergency systems. If the cleanroom requires an emergency electrical system, Article 700 provides requirements for the design, installation, and testing of the system. Ninthly, Article 701 addresses legally required standby systems. If the cleanroom requires a legally required standby electrical system, Article 701 provides requirements for the design, installation, and testing of the system. Lastly, Article 702 covers optional standby systems. If the cleanroom includes an optional standby electrical system, Article 702 provides requirements for the design, installation, and testing of the system. It's important to consult the latest edition of the National Electrical Code, or NEC, and any applicable local amendments to ensure compliance with all relevant requirements. Additionally, working with a qualified electrical contractor who is familiar with cleanroom requirements can help to ensure that the electrical installation meets the necessary standards for safety and cleanliness. Remember to consult the specific requirements of your local jurisdiction and any applicable industry standards for cleanrooms. These standards may include additional requirements for materials, design, and construction. By following these guidelines, you can help to ensure that the cleanroom meets the required standards for cleanliness and safety.